back. Hi, Miss Russell. So this is my brother Georgie, and I will be teaching him about equilibrium today. Woo! Okay. So Georgie, what do you think the best thing about learning about equilibrium is? What do you think it is?
No idea.
It is. Ready? Drum roll. That nothing changes. But ding. Did you hear me?
Yes, I heard you.
All right. So, do you have any questions before we actually start going into the lesson, or the basic introduction at least?
Oh yeah. What is equilibrium?
Okay, so equilibrium is basically a state in which a process and its reverse are occurring at equal rates so that no overall change is actually taking place. Okay? Good? All right, so this is the basic reaction that I have given you right here on this board. And it's A as a solid plus B as a gas. And it's in equilibrium with C as a gas plus D as a gas, okay? And this, we'll be learning about the Chatelier's principle today, okay? So, let me give you this. So, if we increase B, which is a reactant, where do you think this reaction will shift, left or right?
To the right.
You think it'll shift to the right?
Mm-hmm.
All right, so you are correct, but let me tell you why. So whenever you try to increase something here, the system will always try to undo this change of increasing. So it'll actually make the B decrease. This meaning that since in order to decrease a reactant, you have to shift this to the right, which you are correct. That's what you said before. All right. So, what if we decrease? I just gave you the increase, right? So what if we decrease B? What do you think?
To the left.
It'll be to the left, right? Why?
Because the system tries to undo like the changes.
This change, right? So it'll try to increase it. We'll do the opposite of the increasing the concentration of B.
Mm-hmm.
The first one, the one before that. So that's the first one, okay? So this is a product. This B is a reactant, and C and D, A and B are reactants, C and D are the products, okay? So what if we try to increase the concentration, which is a product, C?
It'll move to the left.
It would move to the left, right? So you think it'll shift to the left?
Yes.
All right, so if we increase the concentration of a product, it will shift to the left, as my brother just said. And as it shifts to the left, the C will decrease because the system is trying to undo that
change.
Yes. Good. So since C is a product, of course, it will be brought down to its equilibrium, because that is exactly what the system is trying to do. It's trying to get it back. It is always trying to reach equilibrium. Okay? So, what if there is an increase in A? And as you can see here, A, out of all this, A is a solid. Yes, right here. So what if we try to increase A? What do you think it will do? What do you think? Will it shift at all, or will it shift to the left or to the right? What do you think?
Shift.
It wouldn't shift. Good. It wouldn't. So if there is an increase in A, there will be no change whatsoever, because solids and liquids have no effect on the equilibrium, okay? So this means no change. All right? Mm-hmm. Okay, so do you know what a catalyst is?
A what?
A catalyst.
No.
You don't know what a catalyst is?
No.
So a catalyst is what you use to speed up a reaction, okay? So what if we were to add a catalyst to this reaction, okay? So try to think. If a catalyst speeds up a reaction, what do you think it will do to the shift?
It will move to the right?
No.
To the left?
No. It would have...
Come on!
You have 5 seconds. 5, 4...
You won't change it all?
Yes. So there will be no change at all. Okay? Alright?
Mm-hmm.
So what if we try to add helium? Do you know, you've heard of helium because you take science, right? Yeah, of course you do. That's a tough question. So, helium. So helium is what we know as a noble gas. Is what we know as a noble gas. So if we were to add a noble gas such as helium right here, but an increase in helium, do you think there will be any change at all, or do you think it'll have a shift to the left or the right?
If helium's a gas, it will shift
A
to
noble
the right.
gas.
Oh, noble gas. The right? Shift to the right?
No.
The left?
No.
No shift?
There will be no change at all.
Come on.
No change. Dang, Jordy.
It's because I thought since helium was a gas, like, you would have
It's a
to
noble
move
gas,
to the
yeah.
right.
So there's an increase in helium, which is considered a noble gas. So if you put any noble gas, and there will be no change at all in the end. Okay? So, alright. So, what if we have an endothermic reaction? Okay? So, do you know what an endothermic reaction is? No?
Heat?
Yes, okay.
Heat and pressure?
Okay, wait. It's something with heat. So, it's where heat energy is
absorbed.
Yes, it's absorbed. Okay. So, an endothermic reaction is where heat energy is absorbed. So what if we increase the temperature, okay, in this endothermic reaction? Will the reaction shift to the left or the right?
To the right. Is that wrong?
Okay. So what I want to show you here is, so we have an endothermic reaction. Say this was the endothermic reaction. So you can heat delta H, you can treat delta H, which is this. Alright, that's delta H, remember triangle. I'm using that. Yeah. Delta H as if it is a reactant right here.
Mm-hmm.
So, therefore, since you would treat this as a reactant, this will shift to the, what did you say?
The right?
Yes, you will shift it to the right. You are correct on that. So, and if it decreases, where will it shift? It will shift to the left. So what if we have an exothermic reaction? What do you think? No. Exothermic is, well, it's not the opposite of, well, it is the opposite, but it still has to do with heat. But, where do you, if this is an exothermic reaction and we decrease.
Move to the right.
It would move to the.
Left?
Right. Huh?
Right?
Yes, it'll move to the right. And if we have, sorry, I know, it was my fault. And if we increase it in an exothermic, it'll move to the left. Yes. So I'm going to give you one example, an actual example of the Chatelier's principle. Okay?
Okay.
So, example time. So, HF is an aqueous solution, okay?
An aqueous solution?
It's an aqueous solution, yeah.
Aqueous.
Okay, here. And it's in equilibrium with H plus, which is another aqueous solution.
Aqueous solution.
Plus F minus.
Plus F minus is another aqueous solution.
Okay, so what do you think will happen if we try to increase the pH level? The pH of the solution.
Where's the pH?
Okay. I don't know how to explain this to you. So that we're not talking about the element. Okay, we're just talking about the pH in this solution right here, because in this the reaction that's going on. Okay. All right. So this, don't think of it as an element, as one of these. Okay, but it does have to deal with an element. Okay. So the pH. So whenever you say a pH is increasing, this means that we are basically increasing hydroxide, and hydroxide is OH minus. Okay. So when you're increasing the hydroxide ion concentration, and this means that the H plus right here, now we're going to go into these right here, the H plus will decrease. Okay. So when you have OH, when OH is a base, it will react with this H plus right here, okay? And basically it will neutralize it, and it will come out to H2O. So whenever you do OH minus plus H plus, it'll equal H2O, okay?
Water.
Yes, because you're trying to neutralize it, yes. So where do you think the reaction is shifting? Remember what I was telling you about the products decreasing?
Hold on. H2O is a liquid, and you said liquid doesn't have an effect, so it won't change at all.
No, but look, H plus is decreasing, okay? So where do you think the reaction will shift? Try to look at that. H plus
is decreasing, so it will move to the left. No, right.
Yes, it'll move to the right. So this will shift to the right, and therefore it'll bring H plus. It'll change it because the system wants this to change, and it'll change it back to. This is decreasing. What is it going to change it back to?
Increasing.
Yes, it'll increase at the end. And so then, since H plus is increasing, the HF will decrease. And the F minus will
increase.
It will increase, yes.
And
so that's all. That's what I have for you today.
H plus. Oh, that's the H plus.
Yes, that's H plus, and it'll increase.
And
so
we're done.
We're done. Thank you, Miss Russell. Bye.
And we're out.